Welcome to Beans and Bedrock.
Hello everyone and welcome back to Beans and Bedrock. My name is Anupam and this is the channel where we go deep on Java, Spring, AWS and AI. Today I want to show you a bug. Not a crash, not a stack trace, not a red line in your logs. This one ships. It passes code review, it passes your tests and it sits in production, quietly making your application slow. Here is how you meet it. Somebody says the orders page feels sluggish. You open it, 50 rows. The controller is 10 lines long. The repository is one query. And the page takes 4 seconds. So, where do 4 seconds come from if there is only one query? Well, there is not only one query. There are 101. And 100 of them are invisible because you never wrote them. This is the N+1 query problem, and today we are going to watch it form. Query by query by query. Before we open a single line of Java, let me take you to a hardware store, because I promise you it is the same bug. Picture one of those proper old hardware stores. Narrow, wooden counter, brass bell, and here is the important part. Nothing is on the shelves. Everything lives in the stock room out the back, and one man is allowed in there. You walk up with a shopping list, 20 items, washers, brackets, hinges. Now what should happen? You hand him the list. He reads all 20, goes to the back once, comes out with a tray, and you go home. What actually happens is this. He takes your list, reads item 1, walks to the back, comes out, one washer, reads item 2, walks to the back, and here is what makes this so sneaky. Each trip is fast. 8 seconds. Nobody complains about 8 seconds. But 20 of them is nearly 3 minutes of standing at a counter watching a man walk. And behind you, a queue is forming. Because there is one stock room, one man, and now everybody is waiting for him. Hold on to that picture. The list, the trips, the queue. Okay, let us put that hardware store into Java. 2 entities. Order has an ID, a status, and 2 associations. A customer, a many-to-one, marked lazy, and a list of line items, a one-to-many, also lazy. And customer, which is boring on purpose. Now the repository. One method. Find by status. Spring Data writes the SQL. Select everything from orders where status equals paid. One query. Nothing wrong here. And now the controller. Look at this carefully, because this is the whole bug, and it is about 6 characters long. We take that list of orders. For each one we build a small summary. The ID already in memory. Then order.getCustomer.getName, and then order.getLineItems.size. That is it. That is the bug, because customer is lazy. Lazy means Hibernate did not load it. It handed you a proxy, a stand-in that looks exactly like a customer and is empty inside. Call getName on it, and it has to go and fetch the real thing, which means a query, one query for one order. And line items is the same story. An empty wrapper that fires a query the instant you ask how big it is. Now put both of those inside a loop that runs 50 times. And trust me, I have shipped this exact bug more than once, because it does not look like a database call. It looks like a getter. So let us go and watch it happen. Turn on SQL logging, reload the page, and read the log one line at a time. Query 1. Select from orders where status equals paid. 50 rows come back. That is the query you actually wrote. Query 2. Select from customers where ID equals 401. Query 3. Select from customers where ID equals 402. Query 4. Same shape, new ID. Query 5. Same. 50 of those. One for every order. And then the collection wakes up. Query 52. select from line items where order ID equals 1, query 53. Order ID equals 2, another 50. Final count, 101 queries for one page. Sit with the shape of that number, because this is the part that gets everybody. It is 1 plus n. One query to fetch the list, that is your 1. Then n more, 1 for every row it returned, that is your n. The 1 stays 1 forever. The n grows with your data. But here is what I really want you to take away today. There is no query in your code. Not one of those 100 queries appears in a file you have ever written. No repository method. No @query annotation. No SQL string. 100 round trips are hiding behind a dot, and nobody reviews a dot. And because everybody tries this next, making that association eager does not fix it. Eager does not mean joined. Hibernate still runs those same 50 selects. It just runs them before you ask. Right. So how do we fix it? We go back to that hardware store and hand the man the whole list. Option 1, and the one you will reach for most often, is join fetch. Let us read it line by line. Select O from order O. That is our root, aliased as O. Join fetch O dot customer. And fetch is the word doing all the work. A plain join would only let you filter on the customer. Join fetch says bring the customer back with the order fully loaded. Left join fetch O dot line items. Left, because an order with no line items should still appear. A plain join fetch would quietly drop it. And then where O dot status equals colon status. Run that and the log looks completely different. One query, 200 rows instead of 50, because each order repeats once per line item. Hibernate assembles them back into 50 orders for you. 101 queries became 1. One note. On Hibernate 5, you needed the distinct keyword to collapse duplicate parent rows. On Hibernate 6 and above, you do not Hibernate deduplicates parents by default. If you are on a modern Spring boot, take it out. Option 2 is the entity graph. My favorite when I do not want to write JPQL. Put at entity graph attribute paths on top of a plain derived method. Same result, and your method signature stays readable. Two traps, because if I sent you away with only join fetch, you would hit both within a week. Trap 1 is pagination. You add a join fetch to a method that returns a page. It works. But look at your log. First result, max results specified with collection fetch. Applying in memory. Read that again. Applying in memory. Hibernate cannot put a limit into that SQL. It would slice through the middle of an order's line items and hand you half an order. So it fetches every matching row, pulls the whole thing into your heap and pages it there. You asked for 50 orders and got the table. The classic fix is 2 queries on purpose. Page the IDs, then fetch those IDs. Good news though, on Hibernate 7.4 or newer, this is fixed in the ORM. It pushes the limit into a nested subquery. So check your version first. Trap 2 is the multiple bag fetch exception. You try to fetch 2 collections at once, line items and shipments. Hibernate refuses to even start. Cannot simultaneously fetch multiple bags. A bag is what Hibernate calls a list with no ordering. You can switch those lists to sets and it will run. But now 12 line items times 3 shipments is 36 rows for one order. A Cartesian product. You did not fix it, you moved it. So there is a blunter instrument. One line of properties. Default patch fetch size 50. Now Hibernate collects the IDs it needs and asks for them in batches with an in clause. 101 queries become 3. No refactor. One property. Okay, we saw all of this. Let's quickly do a recap. The problem, a lazy association, read inside a loop. One query for the list, then one more for every row in it. 1 plus N, the fix. Tell the database what you need upfront, join fetch or an entity graph when you know the shape, batch fetch size when you do not, and the payoff. This part is not about milliseconds. Remember that queue behind you at the counter? That is your connection pool. If one request holds a connection for 250 milliseconds and you have 10 connections, you top out around 40 requests a second. Get it down to one query and 6 milliseconds, and those same 10 connections handle over 1,000. Same hardware. So, here is your homework, and it takes 5 minutes. Turn on SQL logging. Load your busiest page. Count the lines. If you see the same select over and over with only the ID changing, you have found one. That is it for today. If this helped, do hit like, subscribe for more Java and Spring deep dives, and I will see you in the next one.